Hope you're doing great. Here we are. Believe it or not, here comes 8-5. Get excited, okay? We're going to be doing some different stuff today. You're going to hate it or you're going to love it. I guess that's kind of true with everything we do, okay? But it's called factoring. Factoring. We are going to factor in a whole bunch of different ways, a whole bunch of different methods, okay? Today we're going to learn one of the methods, grouping. We're going to learn greatest common factor as well. And then we're going to do this weird thing called the zero product property. Sounds kind of interesting. Okay. Anyway. All right, guys. Let's have at the fun here. Use the distributive property to factor. Now, this might look familiar because we did a little bit of this in 7th grade, but we kind of step up our game here. Okay. So we are going to factor 15x plus 25x squared. Okay, so we need to come up with the biggest number and the biggest variable that we can divide into each one of these expressions, okay? So number, not bad. What's the biggest number that goes into both 15 and 25? Okay, all right. What's the biggest variable that could go into x and to x squared? It's kind of a weird question, isn't it? All right, it just happens to be x. If you think about it, I have one x here. I have two x's here. Well, I can take one x, all right, away from both of them. Here you go, right? This is the opposite of the distributive property, right? We are undistributing, which we call factoring, okay? So guys, what would go in here? What expression would go in here that when I multiply it by 5x, it turns into this? Well, if you know, great. If you don't know, all we're really doing is dividing. What is 15x divided by 5x? Well, that's going to be 3. Okay? I can check this. 5x times 3 is indeed 15x. Okay? Again, if you want to do it piece by piece, you can do that. Right? This is a bad plus sign, but it's there. What's 25 divided by 5? Okay, that's 5. What is x squared divided by x? Right? This is why we did all that exponent work in chapter 7. X to the second power divided by x to the first power. Keep the base x, subtract your powers, right? Voila, okay? So this is what we call factoring with a greatest common factor. It is the easiest of all of our factoring methods, and it will always be the first thing that we look for. Is there a greatest common factor that I can factor out of this expression? In this case, it was 5x, okay? All done when I get here, folks. All right? We've got another one here. Okay. I really like that color right now. All right. I've got a trinomial here. Again, let's start with our biggest number. So 12, 24, 30. Well, I know a 2 goes into all of those. How about a 4? Yes? 4, 4. Ooh, no. Wait. 6, 6, and 6. Okay, I don't think there's anything else. So let's go with 6, okay? So 6, now let's look at our x's and then we'll look at our y's. I've got 1x here, I've got 1x here, I've got 2 x's. So at most I can only get rid of 1x from everybody. 1y, 2 y's, 4 y's. Okay, only get rid of 1y. All right, what expression is going to go in here? Well, all we have to do really is divide. 12 divided by 6 is 2. And then again, x divided by x, y divided by y, that all goes away if you think about it, right? It turns to 1, which multiplied by the 2 just stays the 2. Okay? 24 divided by 6 is 4. Again, my x's go away. Y squared divided by y, just that. 30 divided by 6 is 5. What are we going to have for variables here? Again, keep the base, subtract the powers. Right? This is going to be x, y cubed. Okay? How do you know if you use the biggest number, right? Like in this case, 6. Well, look at your remaining coefficients, 2, 4, and 5. Is there a number that we could use, other than 1, of course, that would divide into all of these? No, there's not, okay? So that's how we know we picked the right number. Had we only used a 2 here, we would have been, oh, hey, yeah, you can factor out a 3 out of all of those numbers, okay? And then we would know it's not the biggest number. All right. Again, if you want to pause this and try these, you can. If not, we're going to go a little bit quicker here. So again, biggest number, biggest variable. Biggest number is 3. Biggest variable is xy. Okay, what are we left with here out of this first term? 3's divided into 1. That divides to x. That divides to 1. 1 times x times 1 is just x. 12 divided by 3 is 4. X divided by x goes away, and we're left with a y. There you go. Okay, pop this one down here. 3, 15, 27. Look, the biggest number, guys, can't be any bigger than this number, than the smallest number, right? The greatest common factor can't be any bigger than their smallest number. So I know 3 goes into both of those, so we're going to go 3. Same thing. Once you have one variable, a, and a, like it's just you're not going to be able to do a larger variable than that. B to the second, b to the second, b to the third. Okay. Bear trap, waiting to happen right here. Bear trap. Cancels, cancel. Everything cancels out here. So does that mean I don't put anything here? It means you put a 1 there. Think about, remember, you check your answer, apply the distributive property here, right? Okay, so that makes sense. That would give me here. All right, so what are we going to put here? This is going to be a 5. A. Okay. My last one will be 9. B. Okay. If you want to check your work, like I said, distribute. Okay. It's all going to work out. Factor by grouping. This is my most favorite thing to do. And I want to go do that right now. I'm going to come back to these here in a second, guys. Factor by grouping. We're out of order here in our notes. That's okay. So fast forward down here. Factor by grouping. So we factored by greatest common factor. Now we're going to factor by grouping. Okay? These are our 2 methods for today. What do we notice here? Well, we're going to notice that there's 4 terms. And anytime I see 4 terms, this is automatically what we're going to do. Okay? I am going to group the first 2 terms together. I will group the second 2 terms together. Okay? Now, factor with the greatest common factor. So biggest number, biggest variable, I can factor out of this. Well, no number other than 1, but each one of these we could factor out an x. And I'm left with 2y plus 7. Okay? The cool thing here is that I want to factor numbers and or variables out of this expression to make it identical to this. And this will always work, okay? So what number or variable could I factor out so that I could turn this into this? Kind of a bad example to start with here, right? There's no variable, and I noticed that, look, this is 2y, that's negative 2y. This is positive 7, that's negative 7. So I kind of need to turn all of these into their opposite. So we're going to factor out the dreaded negative 1. Okay? When we do that, yes, this will turn this into 2y plus 7. Okay? In order to factor by grouping, these 2 binomials have to match identically. Okay? When they do, you've done this right. This is part of your answer. That was terrible. 2y plus 7. Okay? There is a second binomial that goes right here. Where do you get the factors for it? From the 2 things that you factored out. So x and negative 1 come together here, and it looks just like this. I wonder what would happen if we FOILed this. Well, if you're curious, pause the video and find out. If you just want to take my word for it, it will turn into what we started with here. Okay? Factor by grouping. This is one of my more favorite methods. I love to factor, right? I love a lot of parts of algebra. This is definitely one of them. Factor by grouping. It is the only method that we have for 4 terms. So when you see 4 terms, guys, I want you to go ahead, group the first 2, group the second 2. Okay? What is my greatest common factor here? Well, 4 and 3, that would be the number 1. X, Y, and Y. All I can factor out is a Y. 4x plus 3. Think about that. I'm going to turn this expression into 4x plus 3. Right? And I've had some people, guys, they'll literally write that in here and then figure out what to divide by. And that's okay. Greatest common factor. 20 and 15. So I think my greatest common factor here is a 5. X with nothing, so no, I can't factor out an x. Now, if I think ahead, if I factor this out the way it is, what's this first term going to turn into? Well, it's going to turn into negative 4x. That's not what I want. I want positive 4x. So we're going to factor out a negative 5 here. When I do that, I feel like I'm going to need more room here. This is going to turn into 4x. Watch your signs. What's negative 15 divided by negative 5? Oops, positive 3. Okay? Again, these both match. That's what I need to have happen. Okay? It doesn't really matter the order you write these two binomials in, right? No, absolutely not. Remember, multiplying doesn't make a difference. Okay? The second binomial comes from these two terms that we factored out. Y minus 5. Okay? Factor by grouping. There you go. Okay? Yes. More. 4 terms. The only method we have to factor 4 terms is to group them. Group the first 2, group the second 2. You're going to hear me say this 9,000 times. What is my greatest common factor here? Well, looks like 2. Looks like an x. If you'd like to factor out a negative 2, you could do that, right? Negative 2x. Okay, so I'm left with y plus 5. Okay, if you're not sure if you factored it right, guys, distribute it. Okay? All right, I need to turn this expression into y plus 5. Okay, greatest common factor here, just a 3. Y plus 5. Okay, my two binomials match each other. Bam, I did this right. Okay, there's half of my answer. The other half, that other expression, just comes from these here. So negative 2x plus 3. Okay? Good to go. So guys, that's factor by grouping, right? Again, I really enjoy that. That's good fun. Now, let's go back to those couple slides that we missed here. Right? Let's see what those were all about. Those were word problems. They looked terrible. Okay. A football is kicked into the air. You can all imagine what that looks like. The height of the football in feet after X number of seconds is modeled by that expression. So again, here are seconds. Here is the height. So the height of the football. Guys, I'm holding the football. Kick football, right? Football goes up. Football comes back down. So the height of this football is modeled by that expression, negative 16x squared plus 16x. Factor the expression, then find the height of the football after 3/10 of a second. Okay. So factor this expression. So what is the greatest number and variable we can factor out? Well, we could do negative 16x, right? You could also do 16x here, all right? This will turn into what, guys? X plus, no, it will not, x minus 1, okay? There we go. Remember, this expression gives me my height. Okay. So factor the expression, there we go. If we would have just factored out a 16x, guys, it looks a little bit different. It's going to be negative 1x plus 1. Okay? Again, these are equivalent expressions. They mean the same thing. Find the height of the football after 3/10 of a second. So I'm actually going to go back and use the original expression they gave us here. Okay? And everywhere we see an x, which is time, okay, we're going to replace it with 3/10. So negative 16 times 3/10 squared plus 16 times 3/10. Okay? I need a calculator for that because it's late in the day and my brain will not work. Okay? All right, so times, hey, look, there's the bell to go home. You guys want to go home? Sure you do. What is that, 4.8? It is 4.8. My brain's not all that bad. All right, add those two together. Plus negative 1.44. 3. Okay. So guys, there is the height of our football after 3/10 of a second. 3.36 feet. Okay. Alrighty. Okay. All right, we're jumping on a trampoline. Again, we can all think about what that would look like. And it's modeled by this equation right here. H, again, is the height of the jump, so how high we're getting off the trampoline. T is our time in seconds. Find the value of t when the height equals 0. I feel like we should just skip this. In years past, right, guys? So if you think about what this says, okay? All right. They want me to replace 0 with this. Whoa, 0 equals negative 14 t squared plus 21 t. Okay? We've solved a lot of equations this year. Have we ever solved one that looks like this yet? Answer is no. No, we're about to though, okay? All right. Okay, let's solve it. Here's what we got to do. When I only have two terms like this, right, both of them have a variable. One is to the second power, one is to the first power. Here's what I want you to do. Factor that expression with the greatest common factor. Okay? Go ahead and do that. Greatest common factor. So biggest number, I'll go with negative 7. Biggest variable, t. Okay? Yes, you could have chosen 7t. That would have been just fine. Okay, so this will turn into what? 2t minus, any takers? 3. All right, great. Again, you guys, we're good here. All I did was factor this. Again, this still equals 0, right? This is that 0 product property. Okay? Why do they call this the 0 product property? So 0, okay, I understand that's a number. Product says we're multiplying things. Property, those are just all the properties that we have in math. So this is an example of the 0 product property. Think about what this equation says. It says 0 is equal to this number times this number. Okay? So think of, okay. So the only way we can get 0 by multiplying two numbers is if one of them actually is 0, right? So I'm telling you right now, this number or this number really will turn into 0, right? It has to for this whole thing to equal 0. So how do I solve this equation? Well, the first step, like I said, greatest common factor gets us to here. Because look, we don't really have a good way of solving, we call these quadratic equations because they're to the second power. But if we can make them look like this, now we can use this thing we call the 0 product property, which says, I would like you to take each one of these expressions, okay? Expression 1, expression 2, and I want you to set them equal to 0 and then solve for that variable. Okay, wait, so if I understand you right, you want me to take this, negative 7t and you want me to set it equal to 0, and then you want me to solve it for t, well, I can do that. Divide by 7, negative 7. Divide by negative 7, t equals 0. Okay. Kind of like case 1, case 2. The second case, take that expression, set it equal to 0, solve for the variable. So you mean you want me to go 2t minus 3 equals 0, and then you want me to solve for the variable? I do. Well, we can do that, right? We have solved many equations like this. So add 3, 2t equals 3. Divide by 2, t equals 2/3. Okay? Again, what did I tell you was going to happen, guys? If we multiply two numbers together and they equal 0, one of them has to be 0. Check it out. Whoa, we didn't want any of that to happen. Maybe I can make that all go away. There we go. All right. I told you one of them was going to be 0. It's this one. What number did this turn into? 2/3. Okay. So let's think about this problem. The height of jumping on a trampoline is modeled by this, where h is the height, right, and t is the time. So in other words, if we're on a trampoline, right, and we can all picture we're bouncing up and down, right? Well, when our feet are on the trampoline, that's right here. And then we go up and we come back down. And that's right here. Again, this is the height and this is the time. And guys, if you think about it, and this is so hard to wrap our brains around, at a time of 0, right? Time equals 0. Our height was 0, meaning, right, our feet were right on the trampoline. Then at a time of 2/3, right, so 2/3 of a second, our height is still 0 again. Oh, okay. Again, how long did it take to go from when our feet left the trampoline to when they came back down? That took 2/3 of a second, right? Here's 0, here's 2/3. Okay. Whew, that's a lot, guys. So hopefully there's some more examples, right, in our skills practice and in our book work that involve the 0 product property. But that is what we do. Okay? We take this equation and we factor it, and once it's factored, I set each one of these expressions equal to 0, and I solve for the variable. Okay? You do that, you're not going to have any problems. These won't seem too bad. If you forget to do that, no big deal. Just ask me and I'll help you with it. Have a great day. I'll see you guys later.